So our next presenter is our colleague here from AUB, Professor Abu Salem. So Fatima Abu Salem holds a PhD in computing from the University of Oxford. She is now Associate Professor at the Computer Science Department at AUB. She was Secretary of Special Activity Interest Group on Supercomputing and currently Associate Editor of the Journal of Parallel and Distributed Computing, Elsevier. She's currently pursuing work in reference to data science and big data processing for the public good, most notably in detecting fake news around the Syrian conflict, predicting demand on primary healthcare centers in Lebanon, among other projects, and that will be the topic of her talk.
I'm very happy to be here for the second year in a row. As you've probably heard, my background isn't typically in data science. Well, it couldn't have been possibly the case because of my age, so all of us started off doing something different. I have a master's in mathematics, as you can tell from my very dull presentation, black and white, and research in computer algebra. That's the world of symbolic computing, where, again, everything is either black or white. But then again, with some time, I discovered this interesting area, and I thought to myself, if I'm going to change my research area, it's going to be to a place where I can put my skills to good use. So my research in computing also relied heavily on parallel and distributed computing and cache-efficient also modeling with data structures and application to mathematical software. And I thought that there has to be a place where this can bear fruit in the data science field. My challenges are several-fold today. So we speak about women in data science, and that alone is a big hurdle. The other hurdle I had is to try to acquaint myself with a very gray area of data where things may not necessarily mean what they look to be. And third, trying to bring all that into the region and the challenges that we're having. I personally feel very jealous when people come and say, oh, we're witnessing an explosion of data. And for me, it was like, no, that's hardly the case. We've had our own challenges last year as me and a couple of people in my team tried to bring these expertise into action. I personally was fascinated and remain fascinated about how this kind of field can help disaster relief operations and our problems of wars and refugees and marginalized host communities as well. So we don't just speak about refugees. We have an equally sort of challenged community in Lebanon and the surrounding area. I'd like to begin with drafting some of the challenges that any data scientist, no matter what your skills are, so you can be doing big data processing and know all the machine learning needed and all the mathematics needed, but still cannot progress a single inch. Where the security measures have been of paramount really importance. So in many instances when we went up to NGOs or asked for telephone data and the answer was, this is a high security country, we're worried about chasing terrorists and terror attacks and really that kind of data, the only way we can monitor it is through telephone records or registration of refugees and UNHCR and the like, there is no way anybody is going to lay their hands on. There's also technically, it's a data desert, so people have traditionally been very, very poor at recording data, so many things come and go. You go to public schools and there's hardly any information about students, despite that they're hosting refugee children in and out, morning and evening. There's also the sort of invisibility of data. Sometimes you've got a lot of data just lurking in the drawers, and there's a big gap in what we know from data and when we actually need to know and take action. There's also inequality of data. There's a sort of tremendous interest in Lebanon and NGOs that are flocking, and foreign scientists and reporters flocking. But at the same time, so they generate this data, but then sort of this data is withheld primarily for security reasons. And I figured this was sort of generating an inequality between those who are with data and those who are without data, who are sort of coexisting on the same ground. And the last thing I've also felt that perhaps cultural, I'm not sure, I shouldn't be making statements like these over here, but there's a sort of tendency to, or aversion to sharing data and a sort of aversion to the open data paradigm. And a lot of things I've seen is just because people have generated data that they actually think that they own it. And that, for me, I thought was a bit unethical in the sense that releasing your data might be actually the only way that you can help people, and under no pretext, be it privacy or consent and all that, which I totally respect, should it come at the expense of allowing others to step in and help people. So anyways, just a very quick synopsis of the projects we are embarking on. I chose a couple of them because they're sort of dear to my heart. That's where we began. One of them was to assess the resilience of the Lebanese power grid. The other one is to try and predict spatial and temporal aspects of demand on primary healthcare centers in Lebanon as a result of the refugee influx, and then detecting fake news in war conflicts, taking, for example, the Syrian conflict. Decision making, so we go through this process of trying to understand what happened and then why did it happen the way we see it. What will happen if trends continue, if traumatic events in this particular part of the world happen, and then how can we make better things happen. Some tools of significance, so this is the technical part. Again, our challenge today is to be able to speak to a diverse community, and so that to have you leave and say, I can do data science or in this part of the world. But then again, we have to come back to the maths and computing. So we rely on big data processing, borrowing from our expertise in distributed computing, machine learning, deep learning, reinforcement learning, and one of the projects that I'm not going to talk about today, geospatial analysis as well, because really it all boils down to geography in this part of the world. And then partly using collective intelligence and crowdsourcing. So the first project we tackled last year was about assessing the resilience of the Lebanese power grid subject to attacks. And by attacks, we do not necessarily only mean sort of military attacks. It could be sort of a burden on the network because of the refugee influx, and a diminished national carrying capacity where Lebanon, a country that is still reeling from the effects of a civil war, has not invested in the power network. Well, mathematically speaking, we have this sort of traditional, we examine the power grid and in line with the literature where, say, the North American grid has been established. Our network did exhibit what we call a power law distribution, where in very simple terms it means there are very, very few nodes that are of extreme centrality, and by that I mean either nodes that are connected to a lot of others or power nodes that help connect all the others. And so the problem with such networks is that when subject to random failures, you have a high vulnerability that propagates according to the centrality of the node. So we had to look at this extremely huge graph. Why huge? Not because Lebanon is a very big country, but because the data we acquired from the Ministry of Power and Energy revealed the power grid up to the very finest geospatial coordinates. It could be the power generator in your neighborhood, Bilhai. So we had this extremely big graph, and we looked at it, and we were sort of thinking, how can we start distributing this? We didn't want to sort of immediately borrow from the distributed graph algorithmics that are available. We thought we could just run a connected component algorithm, and we realized that because of how Lebanon is structured, it sort of had many couple of hundred connected components. Well, from the good side, it sort of made our distribution or distributed algorithm extremely easy to do, but then what we eventually discovered is that the network is extremely resilient, and the sort of measures we generated beat the resilience of the North American grid. Kind of funny to think about, but it's just part of our resilience. We might be sort of less advantaged, but certainly more resilient. So the mathematics are there. Of course, this is no place to go into it. And I'd like to go a little bit more into the second project, which is trying to predict the demand in primary healthcare centers in Lebanon as a result of the refugee influx. This isn't your standard time series problem. So we've got districts all over the map, and refugees coming into various medical centers. We've got hundreds of Excel sheets showing us demand. Some time series were stationary, some non-stationary, some random walks, some white noise, etc. And so what we're trying to do is to look at this from a supervised learning, machine learning procedure, in the sense that the demand is not a natural time phenomena. Something was going on. So in addition to your standard sort of weather, socioeconomic background, etc., there was also the war in Syria taking place, and there was geography lurking by. And what we're trying to currently do is to understand not only the effect of what's taken place in Syria at certain points in time, but also where. Is there a correlation between that event happened here in Syria and the demand we observe there in Lebanon? And if the correlation is failing, we will try to understand the mobility of refugees from a sectarian sort of / socioeconomic point of view rather than a geospatial phenomena. Well, the third project, which we certainly are way ahead with, and something we sort of got sufficient funding for here in AUB, is to try to identify fake news with regards to the Syrian conflict. And so, in a nutshell, we're building this platform which scrapes for news and tries to rely on a source of what represents ground truth. So this is completely data-driven. And look at the news and give them a score based on how much they map, how closely do they map to the actual ground truth. And eventually, this is a big data processing problem. Of course, we're generating a lot with the media studies department at AUB, a lot of news outlets, and then trying to incorporate natural language processing techniques to sort of build the features for what could make an article fake or true. But at the end of the day, it's not us who's judging, it's the data that is being mapped against databases that have recorded Syrian casualties across the war. My time is up. So I had promised I should not exceed, and thank you.